performing qualitative analysis. Basically, so this is also done throughout the process. What happens here is we are just prioritizing the risks. So let's have a look at the outputs. Okay, the project documents like assumptions log get updated, issue log get updated, risk register get updated. So once we finish with this process, all these documents are updated. If we talk about the inputs, the project management plan gets updated, the project documents get updated, all the default generic inputs we can consider it. Moving on for the tools, the expert consultancy on similar projects, or somebody who knows the risk analysis methods, he can be very useful here. Different data gathering techniques and data analysis techniques that we have learned, they can come quite handy. The interpersonal team skills also is very, very important. Okay, risk categorization, this is a new term so far, so maybe we can spend a few seconds here, but I think this is quite self-explanatory. What happens here is we are categorizing the risk. I think we talked about this also in the previous process. We categorize it based on in which category this risk falls, whether is it affecting the cost, is it affecting the time, is it affecting my complete schedule, is it affecting my deliveries. So we are categorizing the identified risks in such a way. So that is an important tool or technique. Data representation, we have learned a lot of data representation tools here, but specifically here when we are discussing about risks and all, I think typically there is one data representation tool that we can make use of. That is, what do they call it? I think they call it the bubble chart or the disk chart. So let me quickly explain to you what this bubble chart or disk chart is. So this is, for example, that bubble chart, and then we have a lot of bubbles identified. What these bubbles are, you can see the bubbles are smaller in size and also bigger in size. So the size of the bubble talks about the impact value of the risk. Each bubble is one risk, and if the bubble is bigger, that means it has a bigger impact. And what are these boxes here? On the left, we have the proximity, how close we are to this risk. So that is the proximity. And then this is nothing but the detectability. How easily can we detect that this risk is being, going to happen? So actually, the larger bubbles, they are quite unacceptable. That means the impact of this risk is very, very high. So we have to create the responses in such a way that the size of the bubble gets reduced in comparison to the smallest one. How big is this risk? So we work in the project on reducing the size of the bubble, or some people call it disks. So that's about this data representation tool. It's a very interesting tool, but not quite useful in my opinion. But still, because the PMP guide mentions this, I think it's important that you learn. And I think finally the meetings. This is also an important tool in almost all the processes. Moving on, quantitative analysis. What happens here is this combines the total effect of individual risks, and then numerically it analyzes the total uncertainty of the complete overall project. So again, this is also not done at the beginning of the project or end of the project. This is done throughout the process, throughout the project. Again, this is a very time-taking process while you're executing it on the project, not while you learn it. This is a very long, lengthy, time-consuming, cost-consuming process, right? So many of the small projects, they don't actually do it. They just skip this process. Even the PMP guide doesn't insist that you must have this process in all the projects, because it involves a lot of time. It requires a huge amount of data, the past data and the data from the similar organization in that industry. And then you have to analyze, because there are so many simulation models. This cannot be done on a pen and a paper, right? So there are so many simulation models, computer generated softwares, which requires a huge amount of data for these models to get created. So what they do, the smaller projects, they just don't do it. They skip this, and it is allowed to skip, right? So there is nothing wrong here. But if in case that you are handling a huge project, a complex project, let's say, if you perform this task, there are going to be a huge cost savings and time savings to the company. Of course, the cost of gathering the data and populating the data and analyzing the output of this data, that comes with a lot of cost and energy, of course. But the results that it will give, they are more valuable than the cost that we are spending here. So it's applicable for a complex project, not for smaller projects. Smaller projects can totally ignore this. So let's have a quick look at the outputs. We have only one output. The project documents get updated. What gets updated here? Majorly the risk report. That is the document that gets updated. Why risk report? That's because after this process is complete, there will be updates in the risk priority, right? We have some analysis done. So what are the new risks? As I mentioned in the previous example, the bigger bubble. After we do the analysis, we implement something, and then the bigger bubble becomes a smaller bubble. So the priority of the risk changes. So that is why the risk report gets updated after this process. All right, let's see what inputs we need. Again, the standard ones, the project management plan, we need it as input, project documents, all the standard documents that you can use as inputs, you can use. And the default enterprise environmental practice and organizational process assets are also covered. Okay, moving for the tools and techniques, we have expert judgment. Who can be the expert on this quantitative risk analysis? Because this itself is a huge task. It's a time consuming task. The data can be interpreted wrong if some wrong data collection happened. So we need that expert who already has experience in it. So similarly, all the data gathering techniques can be used nicely. The interpersonal and team skills, the soft skills can be used while you're gathering the data to perform this risk analysis. So representation of uncertainty. This is again a new term. We can spend some seconds here. So every input that we gather for this analysis, there is an amount of uncertainty associated with it. I think we all agree there. So a few probability distributions, like normal distributions, logarithmic distributions, all these logarithmic strategic or statistical distributions are given to reduce that uncertainty. So instead of just choosing the worst case scenarios, or if you use all the statistical graphs, all those parabolas, the bell curves. So if you use all this, the uncertainty becomes lesser. So the data is more and more accurate with the use of these uncertainty representations. And multiple data analysis tools can be used. Typically, as I told before at the introduction stage, a simple math on an Excel sheet or using a pen or a pencil on a blank paper, it is not going to work when you are going to do this. There are some sophisticated simulation tools available. Some simulation softwares can be purchased to do the quantitative risk analysis. Again, they come with additional cost. The licenses are all, they are not free. So what happens here is you have to populate the inputs to this software. The probability, the detectability, the kind of risk or the type of the risk that we are dealing with, all these inputs that we give, and the quantity based on the experience from the previous projects, or it could be from the other industry-wide risks. They are given as inputs, and then we get an output curve. The S curves, kind of an S curve. We get something like this, and we have to interpret the values based on these outputs from the simulation software.